Hello and welcome to the Rivals Workshop tutorial series. This will be the first video in the intermediate section of the characters creation tutorials. In this part we will tackle everything that you may need to know about GML and, well, how it interfaces with Rivals specifically. If you're already in the know of, well, most of it, I still recommend sticking around because there will probably be something you don't know. There is a lot we will tackle today, so this will be probably one of the longest videos of the tutorial series, but hopefully by the end of it you'll be able to, well, read and understand code you find anywhere, basically. I'll try to be as thorough as possible. So let's start with something basic, which is comments. Comments are, well, parts of code that the game ignores in which you can write anything. This is the line comment, and this is the paragraph comment. You can bring this as far as you want, and everything between this is a comment. You use comments to, well, leave information about the code you write. So maybe you want to give details about a specific part of it. Or not. It depends, up to you. But if you're working with someone else, it's important you comment your code because, well, not everyone will be able to read it right away. Next up, we will tackle the most basic concept, which is variables. A variable is effectively a container that can contain data and is referenced with a name. So, for example, I have a variable a, which is equal to 10. If I write a, it's the same as writing 10, but I am referencing the contents of the variable a. Next up, we'll tackle operators and, well, how they work. In GML, you have a bunch of basic math operators, which is, well, addition, there's subtraction, there's multiplication, then there's division, and then there's modulo. So how do you write these? Given your variables, you may want to add to your variable. The basic writing is this. This will increase a by 5. So what happens is that it does the math here and then assigns the result to what's here through the assign operator. You can also multiply by 5 or divide by 5 or subtract 5 or modulo 5. Modulo is the expression that gives you the remainder of the operation, so of a division. So if you have 10 modulo 5, that's equal to 0. If you have 14 modulo 5, that's equal modulo 4, that's equal to 2. If it was modulo 5, it will be equal to 4, and so on. The way modulo works internally is that, well, if you give it a value, if you do a modulo 3, what it does is that it takes the value you've given it and it subtracts the value you're modulating by, so 7, 4, 1, until it can't subtract anymore, at which point it gives you what's left. The unimportant thing about modulo is that you can't do modulo 0. This will cause an error. It's the same as dividing by 0, but basically the computer would break up because it can't subtract. It will try to subtract 0 forever. Internally, this is prevented by an error message. Next up, there are logic operators, which work for Boolean operations. So computers work with Booleans, which are essentially if something is true or false. In in GameMaker specifically, these are not like separate things. These are effectively just other ways of writing 1 and 0. And in for values, everything that is greater or equal to 0.5 is treated as true. So if I write well 4, that is always true. If I write 0, that's false. If I write -1, that's false. and so on. Logic operators work with the true and false status of a statement. For example, well, these are the operators, and you can also write them like this, or not XOR, and then you have, well, greater than, lower than, greater equal, lower equal, and equal. So the difference between this and assignment is that this is what you use to assign a variable. This is what you do to check if something is equal to something else. So this will become true if A is 1, but it will not assign 1 to A. As for these logic operators, I'll quickly draw the tables for each. So let's start with AND. For example, if you give, so the first two AND XOR all take 2 inputs, and you'd write them like this. So A and B, or A or B, maybe A and not B, A XOR B. Not is the only one that takes one argument, which is put after it. So the tables for each. This is not here, and then XOR here. So not, what it does is just flips the bits. The AND will return true only if both are true, or will return true if either is true, and XOR will turn true if only one is true, not if both. So if they're different. Now let's move to data types. So an important thing about GML is that it's not a static type language, like for example C. So in C, what you'd have to do is, if you want to put like an integer into a variable, you'd first have to specify that that variable is an integer, and then you assign the integer. In GML, all variables are dynamic typed, so it depends on the last thing you put in there, and it does it automatically. So if you do this, this is an integer, but maybe I can do this, and now it's a string. Simple as that. Oh yeah, the colon here is used to mark the start of a new line. In other languages, it's required at the end of a line, but it's not required in GML. I just put it out of habit. So the data types in GML are, well, real, which is any number, so 0, 1, 1.5, even this. Then you have, well, Boolean, which is just, well, true and false, but also any real higher than 0.5 is true, and any real lower than 0.5 is false. Then we have strings. Strings are a little different. So strings are defined with like this, and you put anything in this. This is a collection of characters. The point of strings is that put, well, text data in them. They are a different type, so you can't sum them, for example, to a real. This won't work, even if you maybe a 1 in here. In other languages like JavaScript, this would return this, but this is not JavaScript. There are other ways to define a string. This. There is no, in GML, there's no functional difference between the two, but in other languages, this is for single characters. So this will throw an error, and this would be correct. But yeah, there is no functional difference. I use these if I want to have these as strings. Otherwise, it's a bit lengthier. Um, Lastly, there is one very important type of strings, which is done with these characters here. This is what you may know as an F string if you've done Python, and this is what allows you to insert data into a string. So if I have a variable that's 10, that's 19, if I do this, this will become the same as this because we put the variable in the string. This automatically converts the data into a string. This is the notation. You need the dollar sign and then the parentheses here like this. Next up, we have arrays. So arrays are a bit different. They're like variables except more useful in the sense that so this is how you define an empty array, or you can also put things in it. You can put anything in it. You can put strings, you can put whatever, divided by commas. And this is a collection of items. And you can reference each item by referencing the array variable and the index. So each item is assigned an index. This is 0, this is 1, this is 2. And this is, well, equal to 1. This would be equal to the empty string, and this would be equal to 4.2, depending on what you put in the array. You can assign values to it, like here. An important thing about assigning to arrays is that you need to put an @ sign here to specify to GameMaker that it is an array. I'll go over why in a bit. So next up we have structs. Structs are like arrays, but instead of having indexes for each element, you have variables. So this is how you define a struct. And this is how you add items to a struct. Now, if I want to maybe take the first element, the important thing, these are not considered like ordered. There is no order like arrays. What you do is simply call the struct variable, add a dot, and then the variable you want to call. These are called keys, by the way, for structs. But yeah, they work like variables. You assign the data, and this is equal to 9. This also works for assigning and stuff. Next up, we have a couple GameMaker exclusive data types, which are the S-lists. The S-lists are created through functions. So like with this function here. An important thing about the S-lists, they work like arrays. They have indexes for elements. So let's do a equal this list create. Now, an important thing is that once you're done using them, you need to destroy them because the game will not automatically clean them up. So what happens is that you have this list defined in memory that's not used anymore, and it just stays there and occupies memory forever. You need to destroy them once you're done using them like this. You can add items with functions like ds list add. I'll go over function a bit more later. And you can also do this to reference items, though you need to put this symbol before to tell it it's a DS list. So like with arrays, if you want to assign at index 0, this is how you do it. Next we have, well, the last one, which is DS maps. An important thing about DS maps is that they're like DS lists. You need to create and destroy them once you're done. But DS maps work like structs. So yes, map create. So when you do yes map, you give it a map and then a key, which is, well, a variable, string, and then the value you want to assign to it. I don't know the notation to get the value like this, but you can just do ds find value, and you simply give it the map and the key. An important thing I forgot to mention about arrays is that arrays don't work like other data types, same for structs. So if I define this A and do B equals A, B is not going to be its separate array. So what happens is that I have this array here, which is made of various entries, and I have the variable A, which tells me that it's this array, and then I say A0 if I want the first element, right? If I set B equal to A, what B does is, well, tell me that it's actually the same array. Like, it's not going to be a separate array that's going to be created when I do this. It's going to point to the same array, so B equals 0 is still going to point to the array and to the first element of it. So if you want to actually, like, well, I'll show you more clearly. So if, for example, I do a 0 equal 20, what happens is that if I check B0 like this, B0 will also be equal to 20. If I want to actually create a new array, or, well, copy the one, there is a function for it, array clone. You just give it the array you want to create a copy of. Next up, let's go over type conversion real quick. So let's say you have a number, that's not a number, you have a number and you want to turn it into a string. What you do is you simply take your number and put it in this string function, and this will automatically become the string version of this number. Same for reals. If you do real of a string, it will become the number. Importantly, you can't put characters in it, it will throw an error, and the game will crash. Now, let's talk about another kind of operators, which you'll see less around, but are still very important, which is bitwise operators. These are written like this. There are not counts as well. They are the bitwise version of the operators from before. So this first here is AND, and what they work the same, but they work on the bits instead. So if I have a value of 6, 6 in binary is 110, and if I have a value of 3, which is 011, if I do 6 and 3, this will become 010, which is equal to 2. If I do 6 or 3, this will become 111, which is equal to 7. And if I do, well, not 3 should be 1. Oh, though this is 4. Though bitwise is not really. I don't think it actually exists like that, because this is used for Boolean stuff more and not really for bitwise. This is the bitwise not. Not 3 would become 100, which is 4. So yeah, this is the actual bitwise not operator in GML. XOR, so if I do 6 XOR 3, this becomes 101, which is 5. Like what it does is simply compare the bits that are at the same position, and it uses the tables here to do so. These two are very important for optimization purposes. These are bit shift operators. What they do is shift the number left or right. So by how much you tell them to. So for example, if I do 3, shift to the left by 2, this will turn the 011 into 1100 because it moved these two ones left twice. And this is the same as doing 3 times 4 because this is so this is 12. This is the same as doing 3 times 2 to the power of whatever you said here. So 2 to the power of 2. The shift down here, shift right, does the same but in the opposite direction. So this actually turns the value to 0 because it is also an integer operation, not it does like it's the same as doing 3 divided by 2 to the value you said there, so 2. But in this case, so this would be 3 divided by 4, but since it would end up decimal, it actually gets rounded out. These are very useful because this is faster than doing like times 4 or like floor 3 divided by 4. This is way slower than doing 3 shift to the right twice, simply because the computer likes those operations more. Now, let's talk about the meat and potatoes of programming, which is statements. Statements are split in two categories, which is conditionals and loops. Let's start with the most basic one, if. If takes a condition and an operation between brackets, and if this condition is evaluated as true, this is what you need the logic operators for, then the code between these brackets here will run, otherwise it will be entirely skipped. In GML specifically, the if can be written without the parentheses between the condition, unlike in other languages. And you can also ignore the brackets as long as you put a tab here. So the code needs to be indented correctly. But for readability, I do recommend you keep both, simply because it is just easier to look at and understand for people coming to look at your code. The next statement is else. So what else does is if the condition is evaluated as false, instead of just skipping the if and going forward, it does what's in the else block here and then goes on. However, if the condition is true and it does what's in the if block here, it will actually skip all that's in the else block and move on. Now, another nifty thing you may find is ternary operators. These are like small sized ifs. So if I want to assign a variable, but I want to assign it in a very peculiar way, like for example, I have this other variable b, which is equal to 5 or 6. I want to do if b is equal to 6, then a is equal to 3, else a is equal to 2. So this thing I just wrote can be rewritten entirely as one line. A equals, so you put the condition first, which is b equals to 6, then you put a question mark, and then here you put what happens if it's true. So if it's true, we want to set it to 4, otherwise we set it to 3. You use the colon here to split between the what it's set at is if true or what it's set at is false. This is very handy if you want to make your code short and just not have to write way more lines than you need to. Now let's talk about the loop statements. In GameMaker, you have the following, which is for, while, repeat. There's also do, until. These two are bundled together. So these are loops. What they do is basically they repeat a bit of code. I'll start with the simpler one, which is repeat. So what repeat does is that it takes a value here, an integer, and it repeats whatever code is between the brackets as many times as the value of the integer. So if this is 10, any code in here is repeated by 10. Okay, so if I have a variable of a that's equal to 10, this will increase the variable by 10 each time. Also, forgot to mention, but you can do a plus plus and a minus minus, which is the same as a plus 1 and a minus 1. It just decreases the value by 1. This is a very simple loop. You can do a lot with it though, and it can be way lighter than the other loop kinds, which I'll show right now. So next up is the while loop. This one takes a condition instead. And what it does is that when the loop starts, it checks the condition. If the condition is true, then it does what's in the brackets. Then it goes back to the start. It checks the condition again. If it's true, it does what's in the brackets, and so on. This has the potential to loop infinitely if you do something like this. And yeah, this can cause the game to lag and close because of it. So be aware of that. And it does check for the condition each time a new loop needs to start, and if the condition is false, it just moves on and ends the loop. Then we have the for loop. For is a bit more complex. It takes three pieces of information. So there's this here, operation before start. What it does is whatever you write here will be executed before the loop starts. So maybe I want a variable set to 0. Then here is the condition, which is checked before every loop starts. So maybe I want to have this variable be less than 10. And this is the end operation, which happens every time what's in the bracket has ended. So maybe I want to increase a by 1. And this loop right here will loop 10 times. And a will be increased by 1 for each loop. So the first loop, a is equal to 0. The second loop, it's 1, 2, 3, 4, and so on. Lastly is the do until. So this is like a while, but what happens is that you format it like this, and it does, when it gets run, it does what's in the brackets, and it checks if this is true after. So if this is true, then it goes back to here and does whatever, and if it's false, it just continues on with the code. It works like while, but the check is done at the end. I just remembered that I forgot to mention one very important statement, which is the switch statement. So what switch does is it takes anything here, any operation or value or whatever. So you can give it a variable, for example. And then what it does is that you create a set of cases for what the value is. So if in this case we have if a is 0, then this bit of code here gets run. Break is important to put at the end, because if there's no break, even if you put like case 1 here, this code will run for case 0 as well. So you put breaks between cases. So depending on which is the value of A, either of this will run. If the value of A is neither or none of the other cases, you can create a default case, and this will run if A is not any of the cases. It's important that the value you check in the cases is a constant. You can't put another variable, it will throw an error. You need to put constants in here. One more important thing I kind of forgot is the local variables. So we defined variables like this earlier, and these will remain for as long as the object that has them exists. But if you want to have a variable that only works in a single script, which is the text file you're in, you simply put var before it, and it will be highlighted yellow to tell you that it's a local variable. In GML, it's standard to name local variable with an underscore before the actual name for readability. So you know that that is a local variable even without having to see that it's colored yellow. So next up, we'll talk about functions. There are a lot of functions in GML. A function is, well, made by the function name. And then the arguments. Arguments vary by functions. So we have and each argument is split by a comma. What functions do is that they, well, do something and then may return a value. For example, like we saw before, if we have a that's 10, we want to convert it to a string. A equals string a. This is a function that returns a value that is the string, in this case of 10. And here we're assigning this return value to a. That's, well, pretty much it for basic functions. GML offers a bunch of like map functions. So you can do something like for example, round, which will round any given value. Floor for flooring. Oh yeah, we have sign for the sign. So if you put it 1, if you put 14, this returns 1 minus, this returns -1. If you put 0, it returns 0. Point 1 is still 1. You have the trigonometric functions like sine. However, this version takes radians. Instead, if you want to use the non-radians version, you put a d before it. So this is for degrees. And this gives the sine of 13 degrees. There is, well, the cosine and the tangent. There's also arctangent and so on. One last important math function is, well, abs, which gives the absolute value of a number. So minus 124 becomes 124. It just removes the sign and gives you the positive. The game itself offers a lot of functions. You can find them in the manual, in the functions section here. There's a lot of them, and each does something different. They are all documented, almost all of them. And for the ones you don't find in here, usually they're the GML ones. Like for example, we can look for GML abs, and this will return the GML manual page for the abs function. An important thing about the GML documentation is the GML version Rivals uses is very old compared to the one that's currently available. So this documentation might not always be appropriate for Rivals, simply because it might have extra information that just doesn't exist in Rivals. The last thing we'll talk about is custom functions, which are created like this. You put an hashtag define, and then you put the name of the function. Here you can specify the arguments, so B, C. You can also create through GMEdit specifically args, and this allows you to have more control over the arguments. So B, C, but I want C to default to 5. So when I go and call my A function, you can see down here it will have details about the arguments. So I put maybe B as 5, and I don't need to specify C because C has a default value. If C didn't have a default value, that would throw an error saying that there are not enough arguments. So, and here you put your function body, which is, well, what the function does. Maybe I wanna make it so it takes B and it adds C to it. And then I wanna return. So return is a very important keyword because what it does is end the function and return whatever value was given. So if I do a b equals a5, this will set b to 10. One thing I forgot about loops is that if you're like in a while loop, while true, you can end the loop whenever you want by running a break keyword inside it. So this will run all the code that's here, and once it hits break, the loop will end and it will go back to here. Having multiple loops nested within each other like this will make it so this break only brings you here. It doesn't bring you out of this other loop. Instead, you'll need a second break to exit this one. All right, that should be everything for functions and stuff. An important thing about custom functions is that they only work in the script you wrote them in. So that A function wouldn't be able to work in load unless I pasted it at the bottom of the file, like here in test. Now let's talk a bit about objects. So objects in GML are actually just structs that the game takes and displays on screen. So there are a bunch of basic objects Rivals comes with. The most important one is no one. So no one is a macro for -4, which is, well, no object. So if you set a variable a to no one, this will automatically be considered as no object by the game. There are also null and undefined and etc. in GML. Like you have undefined is what variables for functions are set as when they're not well defined. Now let's talk about objects that Rival specifically has. There's this, which is the player object. So all player objects fall under the OPlayer parent. Then we have articles, like article 1, article 2, article 3, article solid, article platform, and for stages, stage main, stage article solid, and stage article platform. So these are all the basic object parents that have macros. There's also other object parents, but basically this first 6 are what you have access to as a player character. We'll ignore the rest for now. And this is the macro for player characters. It's used in places, but this refers to players, all players. This is all to all article 1s, all article 2s, all article 3s, all article solids, and all article platforms. All solids, so all the things you can't move through, all fall under the par block parent, and all the platforms fall under par jump through. And objects are created with this nice function called instance create, which specifying a position and the object type, so maybe object article 1, will allow you to create a copy of an article 1 with all of the data from your character. In this case, it would create the Rostos article 1. This function returns the ID of an object, so you can save it in a variable, and now A will refer to the article 1. Objects come with a default set of variables, so that you can see them, the green ones, like X, Y, sprite index, image index. These are all the basic game maker object handling variables for position, the sprite the object has, and the frame the sprite is displayed as. There's image X scale, Y scale, and so on. And then there's also id, which is equal to self, which is simply the object ID of your object. And if you have an ID, you can do dot and the name of a variable, like with structs, to get that value. So if we, like before, spawned our instance, we can do a.x to get the x value of the instance, or a.sprite index to get the sprite of the instance. An important statement is the in statement, which is used to check if a variable is in an object. So for example, if x in self, this will check if we have a variable named x. This also works for structs. So if we have a struct named a, we can check if a has hex. If it does, then yeah, we can run this if and do whatever we want. Objects are destroyed by this simple function, which takes the object index. So, if it has no index, it will refer to self automatically. If we give it an index, we can do like before. And now this will destroy the article 1 we just created. Anyways, let's talk about scripts. So scripts are, well, what you write code in. Every object comes with a set of scripts in Rivals. These are the scripts for the player object. It comes with an update script, an init script which runs at when the object is created. Actually, let me pull up the scripts page for characters and I'll go over every single one of them. So yeah, these are the explained here. There are a lot of basic scripts we have access to. Like load is for offsets is called when the item is loaded. Then we have unload when it gets unloaded. Also when you have 5 in training mode. Colors, which is for color palette. You can put the colors code anywhere else. It's just there for organization reasons. Like it's much better to have it there because it's the color code for characters is very, very long. Init, which is defined when the object runs when the object is created. So for example, an important thing, if we do this, and then maybe we have b equals 20, b will not be set to 20 until the init of article 1 has run. So what this does is basically sandwich all of article 1's init in here before everything else runs. When we have other init, this is specifically called by all other players, but you define it yourself, so you can like give it all the data you want, and so on. There are a lot of scripts. The main important thing you need to know is that there is a main divide between gameplay related scripts and draw scripts. So one important thing is that among all of this, animation is an animation script, but it's actually a gameplay related script. So the difference between them is when they run. Draw scripts are not sync. So the game runs at 60 FPS. But what happens is that while the logic scripts are run once a frame every time, and always in the same order, draw scripts are kind of just put whenever they can. Sometimes they are even skipped. Like if you have frame skip, maybe for a whole frame, there are no draw scripts. They usually also once a frame, but again, not synced with the other scripts. They just get put on the stack and run when they can. An important thing about this is when it comes to online play, you want to keep the relevant stuff synced, like player position, player movement, etc. So the thing is, draw scripts are not synced online, and what can happen if you put logic in a draw script, it can mess with the sync between the players, and they will both get booted out of the room because they desynced. So draw scripts, like for example post draw, are exclusively for visual things, not for gameplay related things. All of the important character math that isn't related to visuals should be put in logic scripts. One thing I would like to mention about destroying objects is that instance destroy doesn't work on all objects. There are certain objects that that are protected against it for, obvious reasons. Like the game doesn't want you to kill the stage or kill the main menu, but you can do it through some exploits. So there's this custom function called asset murder that, given an object to destroy, it creates a hit effect, which is spawned specifically by this function. And what it does is do this. So hit effects in Rivals are made, the base game ones are made of two parts. There is the effect, which is usually colored with the character's color, and then there's the white part of it, which is kept white. And these are actually two different objects internally, and the main object, which is the colored one, has a variable called white that points to this other object. And when this stops playing, it kills the white object as well. So what we do here is simply set the white to the object we want to kill, and since this is not us doing instance destroy, the game actually, like for example, you put this as a player, it actually kills the player object forever. You can respawn it and stuff, but it actually deletes the player object. Player objects specifically can also be destroyed if their clone variable is set to true. This will actually delete my player object because the clone variable is used by Forsburn clones to tell the game its clones, and it allows the basic deletion clone, or also custom clone, which is the version that doesn't run the Forsburn clone logic. Now let's talk about a very important statement, which is related to object parent macros, which is the with statement. So with takes an object ID here, and all of the code that's within the parentheses is ran once for every object that falls within this ID, and sequentially. So I can do this, and now the code here will run for every player object. The order in which it runs is based on which object was spawned later. So in a 4-player match where I have P1, P2, P3, and P4, this code will run for player 4 first, and then player 3, and then player 2, and lastly player 1. An important thing about with statements is the other macro. So in a with statement, other always refers to the instance running this with statement. So in this case, I am Rosso on maybe player slot 1, if I do with a player, other will refer inside here will refer to Rosso on player slot 1. If I want what's in here to not run for me, I just put this clause at the beginning, and so whatever is in here won't run if the instance running this is the same as the instance being caught by the with. Otherwise, you can just put like an object ID, like we did before, a equals instance. And this will run from article 1's perspective. What do I mean by perspective? So if I do like this, if I write x in here, x will not refer to Rosso's x variable, but it will refer to the article's x variable. So this would be the same as writing this outside. An important thing is that local variables that are defined like this, if you refer to them in here, it will actually refer to this local variable, not a variable name like this in here. Priority is given to local variables that match the name. Importantly, if you want to maybe refer to like a variable that's of the object here, you can just do like maybe this is not a local variable, this is a static variable. This is like this would try to refer to a b variable of the instance we just created. We can do other.b to refer to this b right here. Let's talk real quick about macros in general. You've seen them. They are the red colored ones, like oplayer. An important thing about oplayer and these parent macros is that if you try to evaluate their value, so not use them in a with, these will have the value of the last instance created. So in a 4-player match, oplayer will be equal to player 4. So it's important when using these to not refer to the actual value of the macro, but instead use them for widths so that it can refer to all objects that fall under this macro. There are a lot of other macros that are accessible only through AssetGet. Like this will run this code for all solids, though it is important you don't overdo it. There are like a lot of these macros fall in base rivals objects, and the thing about base rivals objects is that Dan doesn't like us having access to them, so a lot of their data and variables is straight up inaccessible. For example, if you wanna like access to Molo bombs, you just can't. Base game Molo bombs are uninteractable through Workshop, which is a shame, but also, well, what can you do about it? An important keyword for with is all. So this will run this code through the perspective of every object. This is the macro for every object, the parent macro. You can create your custom macros like this. You specify the name of the macro first, and this is what the value will be set as. If you do this will actually crash the game because macros are constants and you can't change the value of constants once you've set them. Another important thing, like local variables, these and like custom functions, these are only available in the script you put them in and not anywhere else. You'd need to copy paste this in the other scripts to make it work. Lastly, there is one more statement that I want to tackle, which is the exit statement. What this does is basically stop the execution of the script here. So everything that's here won't run. Everything that's before will run and hit the exit and just stop. An important thing for like the fines, the fines count as separate scripts that exist inside scripts, so like a subscript. And if you do an exit here, it will actually just exit the fine, the function, and put you back to where you were. This is the same as doing return, but return expects you to give it a value. Or, well, you can also do this if the function isn't meant to return anything, but you do need the semicolon here. Otherwise, it will throw an error because it's expecting at least something. Actually, no, let's get a look at maybe one of the Rosso scripts, attack update. Let's check up there. So this is a bit of an example of written code that I want you to give a look at. This is very simple code, all in all. What it does is in a switch statement, it checks which attack you're doing. This is attack update, a script that runs whenever you're attacking. And in this switch, we're checking which attack we're doing. And in the case of up air, here first we're calling this function, which is a custom function, which is defined down here. And what it does is set this HUD offset variable, which is the one that controls the overhead HUD position on the character. And it moves it up, given to a given value. And this value is defined here based on which window you're in. If you are in hitpause, if you're not in hitpause, and the window is 3, and you were in on window timer 2, so the second frame in the window, there's this other function which spawns a shell. This simply creates a hitbox which does the shell effect. Then it plays this sound. An important thing about assets is that base game assets are gotten through asset get. Character assets like sprites and sounds, you get them through sprite get or sound get. And then it creates this hit effect at this position, and this is the defined hit effect in init. So if you go to init and look for this, you can see here it's defined here. It lasts 10 frames and uses this sprite. The depth variable of this hit effect is set so that it displays above the character. Depth is the order in which things are drawn on screen. And then there's these two variables which you can find on the wiki on the manual for hit effects. There it is. Here they are. These are used for following instances so that the hit effect follows the player's position for 10 frames, which is the duration of the effect. You can also set this to -1 and it will follow forever. Well, that should be actually it. Next time we will be tackling standard workshop code practices. So a couple of smaller things related to how you write code and how certain things should be tackled when writing code for a character, like basic setup for certain code structures and whatnot. Well then, see you next time.